Hi, I'm Justin from the support training team here at Sophos, and today I'll be going over the fundamentals for supporting Windows endpoints. The topics we'll cover are as follows: Microsoft Software Installers, or MSIs. Some components of Sophos endpoint will use MSI packages for installation purposes. We'll look into analyzing install and uninstall failures by highlighting what to look for in the logs. Windows Registry. Sophos uses the registry to store policy information and application settings that can be analyzed and even modified if needed. Windows Services. Sophos runs many of its components as Windows services. Some Sophos services have dependencies and cannot start unless the others are running. Memory dumps. Memory dumps give a full copy of the data that's stored in the system's RAM when a system crash or BSOD occurs. It's possible to look into these to get some preliminary information on the nature of the system crash. The final topic we'll cover is Windows Event Viewer. Make sure you check out the resources we've linked in the description for more in-depth information about each of these topics. Now, let's begin. MSI is the installer package file format used by Windows. MSI packages are called by running msiexec.exe to install, uninstall, and modify products. The log file format will always be the same regardless of the product or vendor, so long as the package that you're running is an MSI package. The logs will be located in C Windows temp directory or in the user's temp directory %temp%. Generally, there will be a UI present when running installer packages, which will allow you to specify different installation parameters and preferences. When this is done, the underlying executable that runs to interact with the MSI package is the MSI exec process. This can also be run from the command line with a few different options: msiexec.exe/i for installation, /x for uninstall, or /l*v for verbose logging. Other switchers are available, but these are the ones relevant for the purposes of this video. For further reading, please check out the link in the video description. Sophos uses MSI packages to install some components of the Sophos endpoint. You'll need to know how to analyze MSI logs to troubleshoot installation and uninstallation issues when they arise. Here we have an example of what an MSI log looks like. Many of the lines in the log will begin with MSI. This allows you to quickly verify that the log you're looking at is an MSI log. When analyzing an MSI log, many errors can be found by searching for return value 3. This indicates that something in the install or uninstall process has failed out. It helps reduce the amount of information we need to parse so that we can quickly find out where the issue lies. The cause of the error can typically be found above the line where return value 3 is displayed. It can be found in two places in the log. The earlier entry in the logs will be the one that is relevant. Note: many custom actions are performed during an MSI install or uninstall. The result of these actions can be seen with a return value. 0 indicates action has not been executed, 1 indicates success, 2 user cancelled, 3 fatal error, and 4 suspended waiting for restart. Some MSI logs may not have an entry for return value 3, and in these cases you can try searching for error 1603, as this is also indicating that something has gone wrong. The number itself does not detail what has gone wrong, but the log line surrounding it will. Other keywords you can also search for are error and failed. Now we'll go over the Windows registry. Sophos uses the registry to store many settings such as tamper protection configuration, policy information, and service startup information. The Windows registry is a hierarchical database that stores low-level settings for the Microsoft Windows operating system and for applications that opt to use it. You can access the registry by running regedit.exe in the Run menu or in Command Prompt. There are 5 registry hives or root keys which contain keys, subkeys, and values. As you navigate down, you will find configuration settings that tell Windows how to operate. When you make changes to the Windows operating system, you'll often find that there are registry keys that correspond to those settings. An example of this is the enablement of group policies to restrict automatic root certificate updates or defining how Windows updates should behave. Note: before making any changes to the registry, a backup should always be made so that the keys can be restored from any accidental deletion or modification. This is done by clicking File, Export. This will export the selected keys, all subkeys, and values. To back up an entire registry, select the computer at the root of the registry and perform the same steps. Registry backups are stored in the .reg file format and can be edited using a text editor. Here are some common registry keys that are good to get familiar with. Applications typically store their registry keys in the path hkey_localmachine software. Another subkey is WOW6432 note. On 64-bit versions of Windows, this holds registry key settings for 32-bit applications. Some Sophos components will run as 32-bit applications, such as Sophos Health and Sophos Encryption, whereas others will run as 64-bit applications. Next, uninstall. This key contains records for each installed application. The key name will usually reference the product GUID, though some keys will reference the product name or executable. You can find out which application each key corresponds to by looking at the values stored within each key. You'll find an entry named uninstall string, which provides either an MSI exec command or an uninstall executable package to be used when uninstalling the product. This is what runs when you choose to uninstall an application from add and remove programs. Pending file rename operations. In this location, you will find any changes that cannot be committed to the system until a reboot occurs. Some Sophos components will require a reboot once an update or install is complete so that the updated drivers can be loaded onto the operating system. This also includes files that were renamed but were also in use at the time. In some cases, the registry key can be renamed for troubleshooting purposes. If this is done, ensure that you return the key to its original name once complete. If a new key was generated, reboot the system and then rename the key back to its original name. Sophos policy configuration settings. If you recently applied new policies to your devices and you want to verify that they've been received successfully, you can check the following location: hkey_localmachine, software, Sophos, management, policy. In here, you'll find information on all of the policies that have been received. For example, expanding out the application control registry key will allow you to see all the applications that have been added to the list, as well as any additional configuration options. Expanding out the updating registry key will allow you to see what products have been assigned from Sophos Central. Next, we'll cover Windows services. Windows services can be viewed by typing in services.msc in command prompt or in the Run menu. From here, you can start, stop, or restart services. Services also have a startup type, which defines how the service will behave upon startup of the machine. The startup type of each service can also be modified. Every service runs under an account. You can check the account used in the Logon tab. Some services rely on other services to be running and will not start if the service requirements aren't met. You can view the service dependencies from the Dependencies tab. For accounts to be able to run services, the Logon as a Service permission needs to be provided to the account. This permission is typically managed by group policies and can be viewed on machine by opening the local security policy snap-in. From here, navigate to Local Policies, User Rights Assignment, Logon as a Service. Service starts and stops are logged into Windows Event Viewer. You can find the details of a service start failure by viewing these logs. In order to modify some services, you will require administrative or additional security privileges. Sophos Tamper Protection is an example of an additional security privilege. Tamper Protection prevents the unauthorized tampering of the Sophos security suite and its services. With that covered, let's move on to memory dumps. Memory dumps are a collection of data stored in the memory when a system crash occurs. Three common types of memory dumps are small, kernel, and complete. Sophos requires a complete memory dump when a crash occurs to perform a full analysis. A complete memory dump is a copy of what was loaded in the memory at the time of a crash. This gives us the whole picture as to what was occurring at the time of a crash. In some instances, Sophos components may be listed as the faulting module. However, this can also be a result of other operations occurring on the system. Sophos scans all files that are accessed. Due to this, Sophos will always be loaded in the process stack regardless of whether an application crash was caused by Sophos or by another application. Windows collects a small memory dump by default. To collect a complete memory dump, open the system properties by running sysdm.cpl. From there, navigate to the Advanced tab and click Settings under Startup and Recovery. From the pop-up window, change the Write Debugging Information dropdown from Small Memory Dump to Complete Memory Dump and click OK. This must be done before a crash occurs, otherwise the system will only collect a small memory dump. A complete memory dump will be about the same size as the memory available on a machine. The size of a dump can be used to quickly determine if a complete memory dump was collected. The more memory on the machine, the larger the dump file will be. It is recommended to compress dump files to reduce file upload and download time. The final topic we'll cover is Windows Event Viewer. The Event Viewer allows you to monitor a machine's health and troubleshoot any issues as they arise. The Event Viewer logs commonly used by Sophos support are application and system logs. Windows Event Viewer is accessed by searching Event Viewer in the Windows Start menu or by typing eventvwr.msc in the Run window or command prompt. The application log contains events logged by applications or programs such as the Sophos Security Suite. The system log contains events logged by the Windows system components. These events include driver and service startup details and can be useful for troubleshooting if a Sophos driver or service fails to start. When analyzing Event Viewer logs, it's important to filter by specific log levels to omit unnecessary data. The log level severities Sophos support will often analyze are informational, warning, and error. Information indicates an event occurred without issues, warning highlights a potential problem that you may want to monitor, and error describes issues in the system or a surface that doesn't require immediate troubleshooting. You can filter out Event Viewer logs using various options such as time, event severity, event source, event ID, and other specific filters. For example, if you're trying to find all the exploit detections that have occurred, you can filter the application logs by event ID 911. If you're trying to find when a service stop occurred, you can filter by event ID 7036. I hope you found this video useful. Check out the resources for this video in the video description. For further assistance, view and post questions on community.sophos.com and go to techvids.sophos.com for more great videos like this one. Thanks for watching.